Alrighty, so it wants us to find out where one function is bigger than the other, so we're going to graph it first. Alrighty, so there's the two functions, and it wants to know where g of x is greater. And so g of x is the blue one. And so I'm thinking about where the blue one is above the red one. And that would be right here. You see how it's above it? And so to find out the interval, it's just from here to here, and you list the x values. So in this case, the answer would be between -4 and -2. Because it says equals right here, that means I want to include those two places. And so the answer comes out to be B. Brackets mean that it includes it. Parentheses mean that it does not. Alright, number 2. Ask me to solve it. Now, when we solved this in class, what we did is we got a common denominator here. And then we worked it out. And if the denominators were the same, we just set the top equal, which is what would happen here. I want to remind you on Desmos that when it says equals, that you can always solve on Desmos, no matter how yucky it might look. And so that's what I want to do on this one, although I can show you the other way too. I'm going to move the other fraction over by subtracting it. Too many pluses. And what I'm looking for is where it crosses the x-axis. There's a whole bunch of gray dots. Any of them that are crossing the x-axis, this is a gray dot, but it doesn't have a 0 there, so it's not that one. So it's only those two. And that means that our answers are -2 and 10. I did. You just can't see it. It's there. I just subtracted it over, and I looked for where it crossed the x-axis. Okay, number 3. This symbol right here is asking you to find the inverse. And so that was just something I wanted to remind you of on that one. If you see something to the -1 power like that, it's asking you to find the inverse. And so z of x is y, and I'm going to change it to x. That x is y, or that's x, so I'm going to change it to y. And it's just asking me to find the inverse. So I switch x and y, and then I solve for y. So I'm going to multiply by 40. Get the y by itself, so add 250. Sure. And so this right here would be the inverse. So anytime you see that f to the -1 of x, or any kind of function to the -1 of x, that is asking you for the inverse. Okay? Alrighty, number 4. It's asking you to factor by grouping. I wanted to show you this one because I know that you know how to do it, but you might not have seen it with those words. You know, whenever you have a trinomial and you multiply the first and the last, and you find the things that multiply to give you that number, that add to give you the middle, and then you make 4 things with it, and then you separate right here, that's factor by grouping. That separating part is factor by grouping. I just wanted to make sure that you had not forgotten what it means to factor by grouping. So after you get to the point that you have 4 things, you find the things that are in common here. So what's in common between x to the 5th and 4x to the 3rd? When I divide out the x to the 3rd, you end up with x squared minus 4 right there, because you're taking out 3 of the x's. What's in common here between 5x squared minus 20? 5. And what are you left with? X squared minus 4. And then so when I continue this, I've got x to the 3rd plus 5, x squared minus 4. Now that's our first step in factor by grouping. But there's actually one more step, because x squared minus 4 is the difference of two squares. So be careful whenever or if a question asks you to factor something, make sure that you factor it out completely. I will tell you, if you would have graphed that equation and graphed that equation and that equation, all three will be the same. So you do need the most simple, which would be that last one. I don't think that was a really tough one. I just wanted you to know what those words meant. 5 and 6 are kind of weird in my opinion. They're not something that I really think is expected in Math 3, although sometimes something like this may show up, so that's what I want to show you real quick. The question is, on which interval is the average rate of change for g of x greater than f of x? So I want the average rate of change of this one to be greater. And so I'm going to graph it, and I'm going to show you what it's asking. When it says average rate of change, it's talking about how fast it goes up. It's kind of like the slope. I do need to put a parenthesis around that power. Remember, if the power doesn't all go up there, you've got to have a parenthesis around it. Okay, so let's zoom in a little bit here. So I want this one to be greater, because that's g of x. So I want purple to be greater, which means I want purple to be going up faster. Okay, be steeper. So first of all, it says 2 to 3. Okay, so here's 2, and here's 3. So is the purple greater between 2 and 3? No, the black is greater. Okay, let's look at 0 to 1. Here's 0 to 1. Now, the purple is underneath it, but look at how fast it's going up. Is the 0 between 0 and 1, is it increasing faster than the black, or is it? Seems like maybe 0, 1 will be the answer. Let's check the others to be sure. So 4 to 5 is up here. See, the slope, when you're thinking about average rate of change, you're thinking of slope. And from 4 to 5, it's not as steep as it is on the black. So it's not 4 to 5. And then D answer, there's not a D answer, so yes, it had to be 0 to 1. Let me zoom back into 0 to 1 to make sure you can see that. So from 0 to 1, you see how it's steeper, the slope is steeper. That's what that's asking about when you see the words average rate of change. It's talking about how steep it is. All right, number 6 is a similar kind of question, except it's only talking about one particular graph. So I'm going to graph it for you, and I'm going to let you look at it and see if you can figure out where that rate of change would be the biggest. Okay, there's the graph. So negative 1 to 1 would be like from here to there. 0 to 1, so compare them one at a time. So negative 1 to 1 and 0 to 1, which one's steeper? Which one? Okay, let me look at it. So negative 1 would be here, and 1 would be up here somewhere. And then 0 to 1 would be from there to there. 0 to 1? This is an interval. It's not a point. So you're looking at from here to here. 0 to 1 is a bigger average rate of change than negative 1 to 1 just because it's increasing faster. Okay, let's look at from 1 to 2. So 1 is up here somewhere and 2 is up there. What do you think? That's pretty big too, isn't it? And then 5 to 8. 5, I can't even get to 5 because it's so fast, because it's going straight up and down. So which one do you think it is? 5 to 8. 5 to 8 is bigger. Normally, when they, if and when they give you a question about rate of change, it's going to be obvious which one it is if you graph it and if you think about every single interval one at a time. And the one that goes up the fastest, the one that has the steepest slope, that's the one that it would be. This is not a common Math 3 question, although from time to time it does show up. So I wanted to make sure that you didn't miss a question like that that might be kind of simple. Okay, next is an absolute value type graph. And they want us to find the largest value that satisfies the inequality. I can show you real quick that you can graph that on Desmos and probably figure it out. If you ever have to solve this, just wanted to remind you, whenever it's less than, what you do is you write it without the absolute value, and then you put less than -5 on the other side, and then you solve it. So you add 2 everywhere. If it were greater, that's where you do one or the other, but when it's less, you just put it all together. Divide by 4. And you get that interval. Now, what the question's asking you is which one of these is the largest value that fits in that interval. So it's saying, if this is the answer, which one of these is largest and actually works? So 5. Does 5 fit in that interval? No, 5's not in between those two numbers. What about 2? No. Does 1 fit? Yes. Does 0 fit? Yes. So it's either 1 or 0, and we want the largest value. So the answer is 1. So sometimes they ask you questions that you know how to do, but they ask the question in a really weird way. And so that's the reason I wanted you to see that one. You can graph this in Desmos. So absolute value for x minus 2 is less than 5. We'll go home so I can see it a little bit better. Our answer is in this interval right here, and I can tell that 5 doesn't fit. I can tell that 2 doesn't fit. I can tell that 1 and 0 do. So that shaded part is where the answer is located if you wanted to graph that. Equals doesn't work on Desmos, but you can always graph a greater or a less. Okay? Questions about that?
So you pick the highest number and how to...
You pick the highest number that's in that interval.
Oh, okay. I was like wondering why you didn't start with 0.
0 and 1 both work, but it said what's the largest value. Okay, number 8. I'll make this one bigger because this is not necessarily a Desmos one. So according to a poll for an upcoming election, 40% of voters are likely to vote for the incumbent. The poll shows a margin of error of 3%. Write and solve an absolute value equation to find the percent of voters likely to vote for the incumbent. Interesting part on this one is it includes absolute value with margin of error. And when you see margin of error, that might make you think that you need to use your formula that we've talked about before, the 1 over square root of n. But we're not going to use that because that's not what the question is mostly asking. Okay? It wants us to write an absolute value equation or inequality. So it wants us to write something like this and then put a less than or a greater than here to solve it. Alright, we want our margin of error to be 3%. And so if our margin of error is 3%, that means that when we subtract it to find the error, we want it to be less than or equal to 0.03. So that's the 3% for the margin of error. We're trying to find the percent of voters that we want, and in the problem it tells me that 40% are likely to vote. So how many ever vote for the incumbent? I want to take that percentage and subtract from 40, and I want that number to be less than 3%. So the way that you write that is x minus 0.40 less than or equal to 0.03. Sometimes they just say write the absolute value.
Would you just plug that in there?
Sometimes they tell you just to write the absolute value. If that's all they ask, that's how you do it. Your margin of error is always on this part. The less than or greater to, less than or equal to is always the margin of error. Now, if they want you to solve it, you can plug it into Desmos, or we can solve it the way that we just solved it right there. It might be hard to get on Desmos, but we will certainly try it. Absolute value, let's see, let's get rid of all that. Absolute value, x minus 0.40 less than or equal to 0.03. And it's hard to see because these are decimals. It's a really small, you might be able to use choices to try to figure it out, but that might be a case where we actually need to solve it. So if I solved it the same way as up there, I'm going to put negative 0.03 less than or equal to x minus 0.40 less than or equal to 0.03. I'm going to add 0.40 on both sides. So let me get that so you can see it. You know, that's small. Negative 0.03 plus 0.40 is 0.37. And then 0.03 plus 0.40 is 0.43. So we're saying that for the most case, 37% to 43% will be voting for the incumbent if our margin of error is correct. And that's hard to tell in decimals just because you can't click on those lines. But if you were looking at some choices, you might be able to figure it out. Okay, number 9, down to some geometry. In the trapezoid, angles C and B are in a 7 to 2 ratio. What is the measure of angle A? Alright, so it's saying that C and B are in a 7-2 ratio. So what that tells me, whenever I think about it, is that whatever A is, when I multiply it by 2, then I can take whatever it is also and multiply by 7 to get C. It's telling me that B is 2x and C is 7x. That's what that's telling me when it tells me it's in a ratio of 7 to 2. Now, in a trapezoid, and actually in any parallelogram, which this isn't a parallelogram, but it sort of is because these are the same and these are parallel. Do you know anything about the angles right beside of each other like this? I mean, look at them. That one's obtuse. This one's acute. So they're not the same. They're supplementary. These two right here are equal to 180. And that happens in quadrilaterals that are not inside a circle. If it's inside a circle, totally different story. But what that tells me is that 7x plus 2x equals 180. And I can solve it and get 9x equals 180, which means x is 20. 20 is not my answer, though. Let's go back to the problem. If x is 20, what's angle B? 40. And what's angle C? 140. Okay, the question asked me, what's the measure of angle A? So I'm really wanting this angle here. And so what would be the answer? 40. In a trapezoid like this, where these are the same and those are parallel, these two angles are the same, and these two angles are the same. And you can kind of look and tell these are both acute, these are obtuse. So think about acute and obtuse. Think about what looks the same whenever you're trying to figure out those kinds of things. So you graph it, you find the zeros, and then what do I do with those zeros? Add them together because it says find the sum. And so I'm going to take 0.5 plus 3 plus 5. I get 8.5, and that would be the answer. If one of them had come out to be negative, I still keep the negative, and then I add that with it. So, all right, on to number 11. This is another one where the problem isn't there. It's x minus 6 over x squared minus 9x plus 18. Okay, so let's say the problem wanted to know where is the point of discontinuity. We did one like this the other day. And when you're talking about discontinuity, you're trying to find where the bottom is equal to 0 because it's discontinuous wherever the bottom is equal to 0. So basically, I'm trying to figure out what's going on the bottom. One thing you can do is you can factor it. You would get x minus 6 and x minus 3. Now, the x minus 6's do cancel, But whenever you find discontinuity, it's only about the bottom. You don't cancel anything. And so your discontinuities in this problem are going to be 6 and 3. Now, just a reminder, if you cancel the x minus 6's, that means there's a hole at 6. And that means there's a vertical asymptote at 3. I could graph that whole thing and see the vertical asymptote, but the hole's harder to see. If you forgot about the factoring, you could just put the bottom in Desmos and then find the zeros there, 3 and 6, and so that are the places of the discontinuity. So that's one way to do it as well. Okay. If you put the whole thing there, you'll definitely get the asymptote. I'm just a little worried you won't recognize that there's a hole, and so that's the reason I'm trying to show you a different way. Alright, number 12. Number 12 just wants you to solve an equation, and we've been talking about it for a few days, that if you want to solve an equation, no matter how weird or complicated it looks, you can just put it in Desmos and then move that part over. Don't forget that you do need a parentheses to make that all be in the power. I'm going to subtract that big number. Get rid of that first thing I have there. Find out where it crosses the x-axis. And then that will give me the answer. It says 10,000. That's a really... Okay, so whenever you're adding rationals together, you need to get a common denominator. But for me to get a common denominator, I really need a factor here. So this is going to be a 2 and a 4 that will multiply to give me 8 and add to give me 6. This is going to be x plus 4, x plus 4. Because 4 times 4 is 16, and also adds to give me 8. Interestingly enough, I can already cancel some stuff, so maybe it'll make it easier for me to add in the end. What is x squared minus 16 factor to? X minus 4x plus 4. And see, there's some x plus 4's that cancel there. So on this problem, if you're doing it the real way, it actually makes sense to go ahead and factor first and cancel, because look, our denominators are now the same. I don't even have to get a common denominator because my denominators are the same. If you try to get a common denominator from the beginning, that might make it really difficult. But now my denominator's the same, so all I need to do is add that. So that's an x, and then combine those. So x minus 3. And so I end up with a. So basically what I did is I factored everything and found some things that canceled on top and bottom, which you can always do. And then I just rewrote the problem. Now you can't cancel it sideways because we're not adding, or we're not multiplying and dividing. But when you're adding, you can cancel up and down if it helps, and it did here because it gave us a common denominator. Now, very quickly, just to show you, you can put that in. Oops. You have to be careful about putting it in, how you put it on those parentheses and everything. Because if you don't have the parentheses right, it won't do it right. And if we think A is the answer, let's just plug in A and see what we get. We should get the same exact graph. Is it the same graph? It is. So we know that's correct. So here's sort of a rhombus. A, B, C, D. You can start wherever you want to and label it. Just go in order, whatever order you want to. It says that AC and BD are 6 and 8. AC is 6. And BD is 8. What is the perimeter of the rhombus? Okay, so what they're doing here, whenever they tell me the 6 and 8 thing, things you may or may not know about a rhombus, I'm going to draw it better so that you can see it. Diagonals of a rhombus split each other in half. So if this is 8, then that's 4 and 4. If this is 6, then that's 3 and 3. And that is true about any rhombus, that the diagonals, when you split them, that they'll bisect them, and so it'll be even. The question's asking me about the perimeter of the rhombus, so it wants to know, like, if I add these sides together, what do I get? How do you think we could find that side right there? Pythagorean Theorem, yay! 4 squared plus 3 squared equals x squared. It comes out to be 5, because that's a 3, 4, 5 triangle. Notice all of the sides are the same for a rhombus, and that's because they're all of the 3 and the 4s. So each side is 5, which means we're going to take 5, multiply by 4, because there's 4 sides, and so our perimeter is 20. Alright, 15. So 15 gave us a graph and an equation. You can use either. The question says f of negative 3 and f of 3, and we want to compare it. It don't want me to find the answer necessarily. It just wants me to see which one is bigger or smaller. Alright, I don't have any labels here, but let's just take a guess. There's f of negative 3 maybe, and here's f of positive 3. Which one do you think is bigger? Probably the positive 3 one. We can also check with the equation. F of negative 3 would go in the less than one. I would get 3, because you take that negative 3 and plug it right there. F of positive 3 would go in this one. I would get 6. And so yes, f of 3 is greater. So still, it's questions you know how to do, but worded in weird ways, and so I just wanted to show you that. Alright, 16. 16 is asking you to match the equation with the graph. I think you can do that on Desmos. And then 17 and 18 are asking you to write the equation of the graph using the zeros. Try those 3 real quick. So put them in a table, make sure you got them graphed, and then you can put the equation in there to try to match it up. I think it's easier to put the points in so that it's easier to match it. It's harder to match it without the points. That one does look like it goes through pretty well and easily. If you can check the others if you want to, but that one does work. Okay, so with 17 and 18, what you're doing is you're finding the zeros. So there's a 0 at negative 3, a 0 at 0, and a 0 at 2. And so you use those to come up with the equation. So this is negative 2, so that's negative 3, so that would, you change the sign and you make it a factor, so x plus 3. The 0 one, when you make it a factor, it's just x. And then the 2 one, when you make it a factor, it's x minus 2, and then squared because it's a double root. Now technically, there's usually a leading coefficient. We might just put an a there. Depending on the problem or how the problem would be written, you may or may not have to fill in that a, or you might have to put that in based on the problem, but you could figure it out based on the choices or whatever. The most important part here was knowing how to get these factors. I would tell you that a would come to be negative because it is going down on both ends, so the leading coefficient would be negative. And I'm just going to leave the a there just to know that there's probably another number there whenever you're doing the problem. On B, again, find the zeros. We've got a negative 4 and a 3. So the negative 4 would be x plus 4. The 3 would be x minus 3. And then it's a double root again, so it's squared. If there was a number in front, that would be fine, and it would be a positive number because it's increasing, it's going up. Leading coefficient would be positive.
Why are we doing opposite?
So to find the centroid here, I do the same thing. 2 plus 2 plus 6 divide by 3. 0 plus 8 plus 0 divide by 3. So we get 10 thirds and 8 thirds. Any questions about that? Don't let the words trip you up. You're going to see a lot of words. Just read it and go along with it. Okay, one more centroid question, and it's a different kind of question because they didn't give me points. What they want me to find is the length of AT. Okay? T is a point in the middle that's equidistant from all the rest. And it wants me to figure out what the distance from A to T is. Okay? You start by drawing a line from A to the other side because that's the median. Okay? And what we found out about median when we did this last week is that if this is 8, it splits it in half, and this is 4 and 4. So we could figure out what the length of A all the way to that is. We can find that whole side by using Pythagorean Theorem, the 6 and the 4. Okay? So 6 squared plus 4 squared equals x squared. 36 plus 16 is 52, I think. And so we get the square root of 52. If you want to write it as a decimal, that's fine. I'm going to leave it as a square root of 52 for now. That's the length of the whole side. Well, if you remember when we did this last week and we talked about the centroid, we talked about how there's 3 parts to that line and how that top part was twice the bottom part. So what we did to find the whole thing to find the part of it is to divide it by 3. And that would give me this part right here. And I can go ahead and find that decimal if I want to. It's 21 point something. That's not what it's asking me. It's asking me this top part. And so we multiply that by 2. And so that is 43.27. Yes, I definitely put this in the calculator wrong. This is not 21.6. This is 2.4. And then we times that by 2 to get this value up here, which is not 43. It is 4.8. Thank you. Alrighty. A regular hexagon. First of all, a hexagon has 6 sides. Regular means all the sides are the same. Okay? And so we want to find it tells me the perimeter, and it wants me to find the area. Okay. If the perimeter is 24, what does that mean about the lengths of these sides right here? They're all 4. Okay? Good to know. To find the area, you're going to have to find an area of a part of it and then multiply. Okay, so I'm going to start from the center. And I'm going to make this little triangle right here. Okay? I know that this whole side is 4, so what do I think this little part right here is going to be? 2. Okay? I need to find this angle right there, because if I could find that angle, maybe I could find some other information that I need. Okay? How many triangles are going to make up this thing? 12. And if I added all of those angles there in the center, that's going to add to 360, right? If I add all the angles in the center together, that would be 360. And there's 12 angles. So how can I figure out what one of the angles are? 360 divided by 12. This angle right there is 30. I'm trying to find the area of the whole thing. So I need the area of that one little bitty triangle. And then multiply by 12. Because there's 2 to make up each little side. But see, the thing is, to find the area of the triangle, I need a half times base times height. I need the height. To get the height, I'm going to use the fact that that's a 30 angle right there, and that's a 2 to find this height. Okay? I'm going to use trig to do it. I want to make that triangle over here. This is 30, this is 2, and this is what I'm looking for, and there's my 90. Sakatoa, which one? Tangent. Because that's opposite and adjacent. So we want tangent of 30 equals 2 over x. Cross multiply, so we have x tangent 30 equals 2. That means that we're going to have to divide by tangent of 30. We need to make sure that we are in degree mode. And I got x equals 3.4. That gives me the height. So the area of the triangle is 1/2 times the base times the height. Okay, that's the area of that little bitty triangle. How many triangles did we say there were? 12. So then I multiply that by 12.